we're going to wrap up DNA. You guys had to do a project right before we left. We were discussing mutations. And so what we see right here in front of us now is mutations. Remember, it's when DNA does not copyright during replication. You know, anything can happen, such as we can have a very short man, short woman. You could have a giant. So over here on the right-hand side, this technically is known as a giant. They are missing a gene that allows them to stop growing. So this is what happens when there is a mutation missing, whether it is it doesn't have to be missing. It could be a deletion of an amino acid. It could be a substitution. It could be an insertion. We're over here for this person who is a giant, or over here for this one who is a very small person. You can see they have little tiny toes over there. Or this could happen. All right, there really was a long time ago, where they had places where they would call sideshows. And those sideshows would be freaks. And they would have these people come and display themselves and what they could do. So this person just had all these, they could have been parts, I don't know from this picture itself, but it looks as though they're little pieces of skin that are circular on their bodies. This guy didn't have the bottom half of his body. Over here, you can only guess what this is. They were conjoined twins. All right, so it was a lot of different things. And in this picture, you can see a whole bunch of different things. And it was the Browning's freak show. We also have a lot of different kind of mutations, even with our own pets, right? So here, this cat didn't have the right length of arms. So therefore, a mutation had occurred during its replication. This cat here also has very short limbs just in the front, not necessarily in the back. This cat here, its bones were something wrong in the front, okay? So this one is talking about the twisty kangaroo cat foreleg bones. So instead of it being long, they were very short. So I don't know if you've ever heard of the midget cat, but midget cats are now they are a formal breed, but they weren't before. They are incredibly tiny. They resemble kittens all of their lives. They have a short stature of legs, their tails, their heads, everything about them. And if you look them up, they're incredibly cute. But most animals started off as one breed, or two or three, and then when they mated, they came up with other breeds after a period of time. So if you think about the golden doodles now, or the labradoodles, those were a mixed breed before. People used to call them mutts. Now they are technically a breed that people will spend a lot of money on because they are purebred. Think about how we were talking about our genes and when they're pure. And we have two capital letters when we're looking at something that is homozygous. All right. So if we're homozygous and we have two capital or two lowercase letters, that was a purebred. In this case, with the dogs or the cats, or think of another animal, if we're having something that's purebred, that means every ancestor in their line was of the same kind of animal. So look at these. This cat here is a calico cat. Now, unfortunately, it has a lot of issues, right? So this is unfortunately mutated where it was not forming correctly in the womb. This one has two faces. This one had the gene that did not allow it to digest anything and just continue to get chubby and fat. All right, this one You can see its foot pad was double the foot, so it's got like 2 feet in one. Here's another two-headed kitten. Here's another two-headed kitten. Kind of looks like Voldemort from Harry Potter. Okay, and here's Gigi at 42 pounds. This is the same cat up here and down here. It's kind of nuts what mutations can do. Now, you should have learned that mutations don't always mean something harmful. They can be helpful. They can be a bunch of things. Here is a one-tailed lizard, so like a two-bodied lizard. And as I said with the dogs, the cats, we can now create new species simply because over time they have adapted to become a new species. So when wolves were around, there were possibly no dogs, or there were dogs, very limited, and then if a wolf made it with a dog and there was a mutt, it wasn't a specific kind of breed of dog. But over time, if those kinds of dogs continued to make those kinds of dogs, then eventually there was a breed of dog. Here is another one. Yes, it can happen to people as well. All right. So this person here had a horn that ended up growing. These two babies were conjoined right here. And this one had, that's my dog. Hold on. This one over here, you can barely see it, but it's there. This is they call it like their twin. And in the womb, they actually kind of consume their twin. And this one, this is the butt end of the other baby that was there, and he's grown up because they could not take it out. And here are the legs. So if I zoom in just a little bit, so you can see, here it is, that part of the baby, or so to speak, his twin, which is a little eerie when that stuff happens. But it's things that happen often. Can people be successful? Yes. There's 2 conjoined twins now that are incredibly successful. The one is a country singer. If you look at her, she only has 2 legs, but she has 2 heads as well. And these gentlemen have 4 legs, so they almost have 2 full bodies. They are pretty successful, doctors are, in cutting some conjoined twins apart. They have done that before. If you look at this one, they're looking specifically at hairy ears and hypertrichosis. It's due to the holondric gene, and it's the Y chromosome. As you can see, it only occurs in males. If you look at that guy up here, look at this. Look at all this hair right here. And then it looks like he trims his, maybe. And then here, all right? It appears in all of his sons. That's pretty wicked right there. I'm not gonna lie. All right. We have polydactyl, having extra fingers. So this is the thumb, but then here's one here. I do know of people who have 2 thumbs, or 2 tops of thumbs. And then this is another one. So these are the thumb areas. And then there are definitely ones who have them what looks like stuck together. All right, look at his pinky here. And then he's got a protrusion right here. So there are definitely things that happen. Now, this is a double mutation of a myostatin gene. And this happens to be the most muscular dog breed. It's not even a breed, I should say. She just happened to have like this mutation that made her this incredibly muscular looking dog. I mean, if I ever saw that dog on the side of the street, I'm not even sure what I would do. Now you can see the salmon that's up in the top. And that fish has this huge fat gene, and then you have this cow, my goodness, same kind of thing, double genes that are added or whatever. Then we have this dominant negative gene. We have a control, and then we have one that's not controlled, and then you can see what it looks like. Okay, so they ended up, yes, for documentation purposes, for research, you can see very specifically what happens. This is regular, okay? It's completely control. It looks normal. This one, it's starting to get bigger, all right? And then it started to deform a little bit over here. And then you look at this one. I mean, look at all of the muscle here and the fat that was growing up in here. You don't see that over here. You don't see that over here. But look at this on the leg. Oh my, that is just nastified. All right, this is gross. Let's look at the next one. I would never have known that this man, seriously, look at this. So this is a Chinese man on the right. 96% of his body is coated in hair. An extra chunk of DNA that could explain his condition. Congenital generalized hypertrichosis terminalis. I mean, I don't think I would want that. Look at his arms down to his hands. And this is probably where the idea of Sasquatch came from. This looks miserable. This guy was known as the Tree Man, and he had what was warts that ended up becoming a disease that ended up, unfortunately, taking his life. But he lived for about 11 years, I think it was, with these warts, and they covered his hands and his feet. He ended up losing his job because they couldn't remove them. There was no cure for it. They ended up having to trim them, but they couldn't get them off. And so over on the left-hand side is him, and they were able to remove some of them from his face, as you can see him on the bottom right-hand side. And you could see that they were able to trim some of them, but eventually they grew back, and it got worse, and his feet got worse, and he ended up dying from this disease. And the disease was caused by a mutation in his DNA. So I'm just going to quickly go through some of the pictures that we have, and just multiple different mutations. Neurofibromatosis, not fibromyalgia. It is a genetic disorder in which the nerve tissue grows tumors. So all of these are tumors. So I guess that's what that picture was up there. So these are they're awful. Tumors that cause serious damage by compressing nerves and other tissues. Those are on the outside. This is something where the face grows tumors on the outside, or, I mean, it just looks like somebody gave her on Snapchat, like one of those, you know what they're called, and I can't even think of the word right now, but you know me. Here is something that my family had, or has, I should say, in their DNA, are cleft palates. Nothing was this severe in my family. My niece Alden had my niece Alden, her bone in her nose blocked both sides of her nostrils, so they had to drill up through her bone in her nose so she could breathe out of both sides. My cousin, she had a hole in the roof of her mouth, kind of like in D. There was a hole in the roof of her mouth, so they had to somehow close that. And a lot of cleft palates, it's like this, where it doesn't close, and then they end up having to get skin somewhere and put skin, and then they close it here. So this is multiple different kinds of cleft palates. So myths and mutants. Work with animals led to the recognition of heritable traits in humans. Stories of heritable deformities in humans appear in myth and legends, like a cyclops, giants. 60 birth defects on Babylonian clay tablets. So that means a long time ago they were documenting it and they were like, wow. So there is some possibility of mutations from a long time ago that were documented, and we now are coming to the conclusion of, wow, that might have actually have happened. So knowledge of those traits played a role in shaping society and social customs and more of those things of choosing a wife and everything else. So what you're going to do now is kind of think about those mutations. How did they happen? Was that one part? Was it multiple mutations in their genes, in their DNA sentence? Was it an insertion? Was it a deletion? Was it a substitution? And then we're going to do an activity.